Welcome to part 2 of our estimation factors and multiples review videos. Question number 9 in the back half of the worksheet asks you for the greatest common factor of 12 and 16. To find the greatest common factor and least common multiple, I taught the students a strategy known as the upside down birthday cake. Here's how you use it. 12 and 16 are my products, so my first step is to create the upper layer of an upside down birthday cake, which is my biggest layer because my two biggest numbers go into the top. I also need to know, let me just double check, 12 and 16, that's correct. I also need to know the first 6 prime numbers, which are 2, 3, 5, 7, 11, and lucky 13. That's just a chant that I use to help remember what the actual first 6 prime numbers are, because these are the numbers that I'm going to see or check for divisibility. And the main difference between finding the GCF and the LCM comes at the end of creating your birthday cake, so you don't even have to worry about that. Let's start with 2 then. Check for divisibility, or in other words, is 2 a common factor of 12 and 16? I know my divisibility rule of 2 tells me that it is, but if you're not 100% sure, check your calculator, do 12 divided by 2 and get 6, and then do 16 divided by 2 and get an exact whole number of 8. So in this case, my answers go in the next layer of the upside down birthday cake, my 6 and my 8. And now in this case, I don't cross out 2, I could use 2 again because 6 has a common factor of 2 again. I do 6 divided by 2 and I'll get 3, and then I do 8 divided by 2 and I'll get 4. So I create another layer of cake and I place my answers to those questions in there. When I've received either prime numbers or these numbers don't have a common factor, I'm done. And I list my greatest common factor by taking the outside numbers that I'm circling and making a G about and multiplying them together. The most common mistake I've seen is students adding these. Now in this case, 2 times 2 or 2 plus 2 will get you 4, but you have to make sure that if it's asking you for the greatest common factor, you take these 2 numbers on the outside and you multiply them together. So the GCF of 12 and 16 is 4. Now the next problem is asking you about prime numbers. They want to know, can you find 2 prime numbers between 20 and 35? The first thing I told the students to do is list those numbers out as I have here, and then start testing for divisibility. Is 20 a lame-o rainbow? In other words, if I were to come up with the factors of 20, is this what it looks like? The answer is no, because as soon as you test for the divisibility of 2, we know that there are at least 2 more factors, 2 and 10. So if it's not a lame-o rainbow, in other words, if it doesn't look like this, it's not a prime number. So 20, in fact, all of my even numbers are not prime. 20, 22, 24, because every single even number is at least divisible not only by 1 in itself, but also 2 and what other number that gets you that answer. And then I can test other numbers, for example, 21. Well, 21 is also not a lame-o rainbow, because not only does 1 times 21 get you 21, but 3 times what would get you 21? You may be thinking, really? That's true. 21 divided by 3 gets me 7. So they have at least 4 factors. We're looking for only numbers that have 2 factors, 1 and itself. I'm only looking for lame-o rainbows. And the very first one that is a lame-o rainbow is 23. 23 is a prime number because it has only 2 factors, 1 and itself. And that's it. So 23 is the first prime number. 25 is not, because not only does 1 times 25 get you 25, but so does 5 times 5, which means it's not a lame-o rainbow. It has more than 2 rings. So it can't be 25. 25 is not a lame-o rainbow. 27 also has 3 as a factor because, well, check it in your calculator. 27 divided by 3 would get me 9. So 27 doesn't work. However, 29 is my next lame-o rainbow, because if I tried to find all of the factors of 29, only 1 and 29 are the 2 numbers that would get me the product of 29 when multiplying them together. The other factor that is prime is 31. 33 is divisible by 3, and 35 is divisible by 5. So there are 3 prime numbers in between 20 and 35. They are 23, 29, and 31. And the way you can check is by creating rainbows, and your LAMO rainbows are the ones that stand out. So 23, 29, and 31 are the answers. They are only looking for 2 prime numbers, so I'm going to go ahead and put 23 and 31 down there. What's the least common multiple of 3 and 5? Here's the great thing about the upside down birthday cake. You can use it for this as well. Let me show you how. I'm looking for the least common multiple of 3 and 5. I follow the same exact steps, which in this case means I start my upside down birthday cake and I write down my first 6 primes, which again, 2, 3, 5, 7, 11, and lucky 13. Well, what you'll notice about 3 and 5 is that even though 3 goes into 3, 3 cannot go into 5 evenly. Even though 5 goes into 5 when I check for divisibility, let me show you. Well, 5 divided by 5 would get me 1. Beautiful. 3 divided by 5 is going to get me a crazy decimal. That does not work, which means 3 and 5 are both prime. In fact, we should have known that, right? Because 2, 3, 5, 7, 11, and lucky 13 are my prime numbers, my first 6 prime numbers, which means nothing else can go inside of that. So the only number that can go on the outside is 1, and now I can put my birthday candles on the top because I'm done. Which means in order to find the least common multiple, I take what's on the outside, which in this case is 1, and the lowermost layer, which in this case is 3 and 5, and I multiply them together. 1 times 3 times 5 is 15. My least common multiple of 3 and 5 is 15. The bottom 2 questions aren't really estimation questions, but you should certainly try and estimate check for reasonables. In this case, Susie bought 18 books. They cost $6. If you want to find the total, multiply 18 times 6. If you're looking for a quick answer, round 18 to 20 by using the rounding rules. Underline the 1, circle the 8, 5 above, give this 1 a shove to a 2. Anything circled into the right becomes a 0. Then do 20 times 6. Well, I know that 6 times 2 is 12, and then I can just transfer my 0 into the answer. So she spent about $120. In a similar fashion, Jack and his television, we can round that as well. We're trying to round it to the nearest $100, which in this case, if he only has $284, you can round that up to $300. And the TV cost $427, you can round that down to $400. He's about $100 short. However, what happens is if he gets a loan for $500 and he pays it off using that loan, you round that to 500, which we already had, and 427 to see what we would get. Well, you have to borrow here, which means 10 minus 7 is 3, and 9 minus 2 is 7, which means he would get about $73 left over. And that's the back half of our estimation study guide. I hope this helps as we get ready for our estimation test.